Hey seniors, today we're going to start talking about comparing graphs and equations. This whole unit we've been working with linear functions and y equals mx plus b, and none of that's going to change except today we're going to be talking about which has a greater rate of change between equations and graphs. And it's pretty simple, but we just kind of got to get the hang of it. So let's go ahead and jump in. On your notes page, go ahead and draw your line. In the top left-hand corner, go ahead and write comparing graphs and equations. Alright, so let's go ahead and remind ourselves about the new vocabulary that we've been learning. When I say a constant rate of change, I'm always talking about slope. Write that in your notes page. I know I've had you do that every day this week, but it's so important. Alright, and then if I hear the phrase initial value, I'm referring to my y-intercept. Write that in your notes page as well. Alright, so these are just some little hints. You don't have to write these down, but you do need to know them. When looking for the constant rate of change on a graph, find the slope between two clear points. We've been working on slope in math intervention to get that extra practice, so we should be super strong with that skill. When determining which has a greater rate of change between a graph or an equation, we want to look for the slope that increases at a higher rate. And I'm going to show you a couple of different problems to figure that out. So let's go ahead and do an example. All right, example 1. The graph below shows the distance traveled between two cars. Car B is traveling at a speed of 65 meters per second, where x represents the number of seconds and y represents the distance traveled. Which equation best describes the equation of line A? All right, so the first thing I need to do here is write an equation for car B. It doesn't tell me what an initial value is. It doesn't say like what number the car starts at, so we can go ahead and assume that it starts at 0 for an initial value, which makes sense because when you start a car, it's not moving, right? All right, so car B. If it says it's traveling at a speed of 65 meters per second, per should tell you that this is going to be followed by a variable. My equation should be y equals 65x. So now I want to figure out which equation best describes the equation of line A. Here are my answer choices. Y equals 30x, y equals 45x, y equals 65x, and y equals 75x. Well, I can go ahead and look at my graph and see that because line A is a much steeper line, line A must be traveling much faster than line B, or car B. So I can go ahead and eliminate y equals 45x and y equals 30x because if my line is steeper, it must be traveling at a greater speed. And we already know that car B is traveling at a rate of 65 meters per second, and since these are not the same lines, we can go ahead and eliminate choice C. And that, of course, will leave me with choice D, y equals 75x, which means that car A is traveling at a rate of 75 meters per second. Now, what we just did there is we did a little bit of estimating because clearly this graph does not have lines on it. We don't actually know the exact speed that car A is traveling at, but because it's traveling, since my line is much steeper, I know it's traveling at a much higher speed than car B. And you're going to have problems like that where you're going to kind of have to look at the graph and determine what the relationship is from there. Let's do another example. All right, which of the following representations of data has a greater rate of change? Which has a greater rate of change? So again, I need to figure out which one has a higher slope. Now, for representation 1, I already have an equation, y equals 75x plus 400. But for representation 2, I need to write an equation based on this graph. So the first thing I'm going to do is, again, I always want to write it in the form y equals mx plus b, where m is my slope and b is my y-intercept. So let's go ahead and start at our y-intercept. This graph is representing parking costs at an airport. So I see immediately that my y-intercept is at 5. So I have y equals whatever my slope is plus 5. So again, the next thing I want to do is find the slope between two clear points in the graph. So if I do that, see that I'm increasing by 1 and going over by 2. However, if you look at this graph, I see that each point is increasing by 5. So that what I'm really doing here is for my rise over run, I'm rising 5 places and I'm running 2 places. So I have a slope here of 5 over 2x plus 5. Now, this one is pretty easy to figure out. Which equation has the greater rate of change? Well, I can already go ahead and look at my slope and see that 75 is much higher than 5 over 2. Much, much higher. Which means that for every 400 places, my representation 1 is increasing by 75 points every single time. Whereas my second representation, which shows in this graph, is only increasing, my line is only increasing by 5 halves every single time. So representation 1 clearly has the greater rate of change. It has the steeper slope. And that's what you kind of have to look for. Now, let's do one where it's not as close. All right. Compare the scenarios to determine which represents a greater speed. Explain your choice by including a written description of each. Be sure to include the unit rates in your explanation. All right, what I'm really interested in right now is which one has a greater speed, which one's increasing. So the first thing I want to look at is scenario 2 already has my equation of y equals 55x. So I know that for scenario 2, my line is increasing by 55 every single time. So that's a pretty large number. What I need to do is figure out what the slope is for scenario 1 and figure out what its rate of change is. So again, what I want to do is find my slope, my rise, and my run. So I have y equals, and I see that my y-intercept starts at 0, so I can go ahead and add that in, plus 0. Then what I need to do is just find another clear point on the graph. And almost all of these bullet points, boom, the one at the top is the largest. So what I need to do is go ahead and figure out the rise and the run between these 2 points. If you look at this graph, you see that it's increasing by hundreds. So once I get up to the top of my triangle for my rise, I see that I have risen 300 spots. Likewise, I have run 5 spots. If I divide 300 by 5, that's going to give me 60. That's going to give me 60. So I have a slope of y equals 60x plus 5. So this is for scenario 1. Scenario 2 is y equals 55 plus x. Now that I have my 2 equations, I can go ahead and determine which one has the greater rate of change. I see that for scenario 2, my line is increasing by 55 each time. Versus scenario 1, my line is increasing by 60 every time. 60 is greater than 55. Barely, but it is greater. And since 60, scenario 1, has a larger slope, that means it's increasing at a much greater speed. So, scenario 1 is the one with the greater rate of change. All right, guys, that's going to be it for me today. Let's go ahead and practice.